Hi there, Pre-Calc students. It's time for Chapter 2 lessons, and today we're going to look at a couple different lessons, 2.1 and 2.2 systems of equations. Most of this should be pretty much a review for you, but we'll let you take a look at some of these examples here. As you can see, this first lesson is on systems of equations, and of course a system means two or more equations. In 2.1 we'll look at just two equations, but we will look at a problem in 2.3 that has three equations. And by solving a system means to find shared solutions. You can see the four methods we have of solving systems, and we're going to go over each of these. The one we're not going to go over on the video anyway is matrices. We'll do that in class. So graphing, substitution, elimination, and matrices. So first of all, we're going to take a look at graphing. And I'm going to use a couple different colors here. We're going to let our first equation here be red and our second one be another color. So I just want to graph each of these. First one, of course, is in our slope-intercept form. So it looks like the y-intercept is at 6, so I'll make my dot there. Slope of -1, as you can see, so I'll count down 1 and over 1. So I'll make my little dots here and go ahead and graph this. I don't know if I can use a ruler on an iPad or not. I haven't tried that, but there you get an idea for what that looks like. Our second equation I think I'll do in blue. This is in standard form. I think I'm going to graph this using the intercept method, so I don't have to change it to the y equals method. Intercept method means I put 0 in for x and figure out what y is. So if I put 0 in for x, of course that term cancels out and I have negative y equals 6, so it's got to be 0, -6 will be one ordered pair. Then I put 0 in for y and I see that x would end up to be 2. So I want to graph those 2 points, 0, -6 down here and 2, 0 here, and try to connect up those. And sure enough, here's a case where I clearly have one intersection. And a little bit tricky sometimes graphing wise to see what that is, but I think in this case we can tell it's going to be the ordered pair 3, 3. And just to double check, I could put that ordered pair in each of these equations and I would see that that works. So the advantage of graphing, solving a system by graphing, is that it's very visual, easy to understand what the solution is. Disadvantage is if you have a strange intersection, it might be kind of hard to do it graphing wise. We'll kind of review in class how to do it using your graphing calculator though as well. Next we have substitution. Oftentimes this seems to be one of the trickier ones for students to learn, but this is still something we'd like you to be able to know how to do. So substitution, usually you're looking for a single variable, like a single y or single x that you can substitute for. So clearly in this case we do have that single y, and we already have it set up equal to that. So basically I'm going to substitute this expression for y in the second equation. So I'm going to rewrite the second equation, but instead of writing 2x plus y, I'm going to substitute 3x minus 8 in place of that y. And I rewrite it like that. Now I think you can see that this is an equation I can solve because now we just have one variable. So I'll do that. So this will be 5x minus 8 equals 22. I'll add 8 to each side, so 5x equals 30. I'll divide by 5, so x will equal 6. And don't forget that we need to get our second value for our ordered pair. So then I go back to probably the first equation here, whatever one is easiest, it doesn't really matter. And I have now know what x is, so 3 times 6 minus 8, so that's 18 minus 8 will be 10. And so my final answer for my ordered pair here will be the ordered pair 6, 10. So that's an algebraic way of solving systems. Some people like this way. Sometimes this is definitely the most efficient way of doing it, but most people algebraically probably prefer this next method called elimination. Now elimination almost always happens when both equations are in standard form as they are, and basically what we want to do is add up columns like this. but before we add them up, we want to make sure that we eliminate one of the variables. Therefore, we're always trying to set up an opposite situation, either with the x's or the y's. And you can see that right now we do not have that. If I added up columns, I would not eliminate any of the variables. So you may recall that you have to perhaps multiply one or both of these equations by a number so we can set that up. And I think you can see that the easiest, most efficient way of doing that would be to multiply this top equation by 2. So I'll multiply everything in it using the distributive property. So 4x minus 6y equals negative 42, like that. My second equation, I remain the same. That sounds kind of silly. Now I'm going to add up these columns, and you can see certainly that now we have one of these opposite situations set up here. And so my y's will be eliminated. Meanwhile, negative 42 plus 15, I believe, is going to be negative 27. And then I can divide by 9, and I can see that x is going to be negative 3. Again, I have to go back and then substitute into one of my other equations to figure out what y is. I'll just go to the second one there. So I have 5 times negative 3 plus 6y equals 15. So 15 plus 6y equals 15. Excuse me. That's negative 3, isn't it? So negative 15 plus 6y. Add 15 each side. So 6y equals 30. And y equals 5. So my solution here for my ordered pair is the solution negative 3, 5. Pretty handy way. Most students kind of like that method. Again, sometimes you have to multiply one or sometimes even both equations in order to get that to work out. Algebraic way of solving systems, and that's using matrices. I think in the interest of time, we will show you that in class tomorrow. You can use your calculator pretty nicely. It's a slick way of doing it, especially when we get to 3 by 3 matrices. But for now, I think I'm going to bypass that. Next comes a little chart that you probably should write down in your notes. This is not the most crucial information in the world, but sometimes you run into these terms. And it has to do with how many solutions we might have with a system of 2 equations and 2 variables. And so these words are just sort of interesting to know, so you might want to pause the video right here and write these down. Alright, next, I want everybody to roll up your sleeves because we're going right into lesson 2.2. Not too many problems, as you can see, that you're going to have to do assignment-wise on this, but they are kind of nasty because problems are going to be not a 2 by 2 system, 2 equations and 2 variables, but as you can see, a 3 by 3 system. And so that's going to make this a little bit daunting perhaps, but we'll kind of muddle through here and see what we can do. Alright, the secret here is again trying to eliminate a variable, and what I want to do is be able to take these kind of 2 at a time and try to eliminate one variable. So notice if I took these first 2 equations, I want to try to eliminate a variable, and just looking at all of them, I think my decision is I'm going to try to eliminate the y variable. So I'm going to leave my first equation the way it is, like this. But then notice on my second one, if I wanted to eliminate y, I think I'm going to multiply everything here by negative 2 so I can set up that opposite situation. So this will be negative 4x minus 2y minus 6z and oh, excuse me, I didn't want to multiply it by negative 2y, did I? How silly of me. I want to multiply it by positive 2y so I could get that opposite situation. So 4x plus 2y plus 6z still equaling 0 on this side. So now notice when I add these up, I am going to get 9x plus 7z equals 11. Doesn't look too promising at the moment, but be patient, friends, because it should work out fairly well eventually. Now next I'm going to take these 2, so the second and third equations. I'm going to do the same thing, try to eliminate the y's. And again, as you see, I'm going to probably have to multiply that top one, the top one meaning the green one here, by 2 once again. So now I'm going to have actually the same thing I had before, 4x plus 2y plus 6z equals 0. Bottom one I'm going to keep the same, 6x minus 2y minus 2z equals 16. I'm going to add all these up once again. I'm going to get 10x, again the y's cancel, plus 4z equaling 16. Doesn't appear to be all that good right now, but now what I have, as you might be able to tell, is I have two different equations here. Now I have an x and a z, so now this is going to be more similar to what I have done before. Now hopefully I don't run out of room, but if you look at these, my choice is I'm going to decide to eliminate the z's. Neither of the options here are real pleasant, but what's going to happen here is I think I am going to multiply, here I think I have a little bit more room, I'm going to multiply the top one by negative 4, so 9x plus 7z equals 11, and the bottom one I'm going to multiply by 7, so that's 10x plus 4z equals 16. And then what I'm going to end up with, I'm going to try to get it on this line here, I'll have negative 36x minus 28z equals negative 44. I'm running out of room. And this one I'm going to have 70x plus 28z equals 112. When I add these up, can't see my writing very good here, I'm going to get 34x equaling 68. Now that's kind of nice. You see that I can divide by 34 and voila, x is going to equal 2. So that's one of my answers. My answers here will actually be something called an ordered triple, believe it or not. Okay, now that I know that x is equal to 2, I can go back to one of my equations, maybe this one, 9x plus 7z equaling 11. I can put that 2 in place of this x, so I'm going to get 18 plus 7z equals 11. Ultimately then I'm going to get 7z equaling negative 7, so z will be negative 1. Ta-da! And then, last but not least, I am going to, now that I know what my x and my z are, I can go back to any of my other equations. I think I'm going to go back to this one, 2x plus y. Hopefully you can see these on your paper. I can't see my other slide here. Equaling 0. I put in 2 for x and negative 1 for z. So I'm going to get 4 here plus y minus 3 equals 0. That's going to add up to y plus 1 equals 0. So y will be negative 1. So my answer here in this case, it's not called an ordered pair anymore. It's actually called an ordered triple. Should be, and they should go in order from x to y to z, 2, negative 1, negative 1. Now when we get to class, I'll show you a real slick way how to do this using matrices. However, when we do a test, I will have you do one of these system of 3 equations by hand like this. It's just good for you to practice to keep things straight and be able to work a fairly tough algebraic problem like this. Alright, thanks for hanging in there today, everybody. We'll see you in class. Bye.